Alright folks, so in today's video we're going to talk about propagation, specifically two aspects, critical frequency and MUF, or maximum usable frequency. I was asked by someone to do a video explaining the differences, so here we go. Stay tuned and let's get started. So I put together a few slides for an introduction. When you transmit from your radio station, the signal travels through the air to reach someone's antenna. It's all thanks to a phenomenon called propagation. But have you ever wondered which frequencies you should use for communication? One critical concept you should understand is the relationship between MUF, maximum usable frequency, and critical frequency. Here's how it works. When a radio wave is transmitted from a station, it travels upwards towards the ionosphere. As it reaches the ionosphere, it interacts with the charged particles present in ionospheric layers. The interaction causes the radio wave to bend back, or refract, towards Earth. Here's where MUF and critical frequency come into play. If the frequency of the transmitted wave is higher than the critical frequency, it will not be able to bend back towards the Earth. It actually penetrates the ionosphere and goes through and into space. To ensure successful communication, it's important to consider the MUF and critical frequency. By understanding these concepts, you can select the appropriate frequency for your communications. So you may be asking yourself, why do I need to know this stuff? Maximum usable frequency, or MUF, and critical frequency are terms used in the field of radio wave propagation to describe characteristics of the ionosphere. Critical frequency is the maximum frequency at which a radio wave can be refracted back to Earth by the ionosphere, while maximum usable frequency is the highest frequency that can be effectively used for communication by taking into account factors like critical frequency and the specific conditions of the ionosphere. So a couple things that you should know, and this is a slide that I put together a while back, and I use it often when talking about things like propagation. You can see the sun, who's very happy, up in the upper left-hand corner, and he is projecting rays towards Earth. These rays charge particles in our ionosphere, and that's the blue line at the top. Now, what we see down on the Earth are two amateur radio operators looking to communicate with each other. Now, we'll typically communicate HF signals at long frequencies through skywave propagation. This is when a signal leaves our antenna, moves towards the sky, and then is refracted down. The angle of which this wave hits the ionosphere is called the incident angle. Sometimes it's more acute, and sometimes it's more obtuse. The more obtuse the angle, that means wider for people who didn't take geometry in middle school, the further our signal or communication will go. There's also other types of propagation, such as ground wave propagations. The distance between the two operators is called the skip distance. The skip distance is broken into two parts. One is the ground wave, so we also have signals that come off of our antenna and travel across the ground. They don't go very far, but it happens. The difference between the ground wave distance and our communications partner is called the skip zone. This is where you may get some backscatter off the downward incident angle, but typically amateur radio communications are not possible. Hopefully this helps. So our maximum usable frequency. It's the highest frequency that allows for reliable communications between 2 points via reflection from the ionosphere, and I probably should have said refraction there. The MUF is dependent on factors such as the critical frequency, the angle of the incidence, and the distance between the transmitter and receiver. Signals with frequencies above the MUF will penetrate the ionosphere and not be reflected, again I should have said refracted, back to Earth, leading to a loss of communication. Let's talk a little bit more about MUF. The maximum usable frequency is not calculated directly. It's determined through empirical observations and measurements. It depends on various factors related to the ionosphere and the specific path of the wave propagation. However, there are models and techniques that are commonly used to estimate MUF. One such method is to use the basic MUF, the BMUF, and the lowest usable frequency, or LUF. The lowest usable frequency is the frequency that is lowest that we can use to make HF communications. Any frequencies below the LUF will be absorbed by the ionosphere. When the LUF exceeds the MUF, HF communications is not possible. The basic MUF is an estimate of maximum frequency that can be refracted by the ionosphere under average conditions. It is determined based on the critical frequency of the ionospheric layer that is most critical for the path of communication. The BMUF takes into account the angle of the incidence, which is influenced by the distance between the transmitter and receiver. The lowest usable high frequency, and that's an HF frequency, but the lowest one that is usable, is an estimate of the lowest frequency that can be used for reliable communication on a specific path under average conditions. It's influenced by factors such as signal-to-noise ratio and minimum acceptable signal strength. And one thing I'll mention, when we use lower frequencies and they go up towards the ionosphere, if we have a more acute angle, the signal will likely be refracted down better than if you have a more obtuse angle. This is because the signal is not going through as much of the ionosphere as it does with a more obtuse angle. The MUF is then estimated as a value between the BMUF and the LUF. The actual MUF can vary based on ionospheric conditions, time of day, solar activity, and other factors. Therefore, real-time monitoring and prediction systems are often used to adjust the estimated MUF for current conditions. Critical frequency refers to the highest frequency at which a radio wave can be refracted or bent back to Earth by the ionosphere. It is the frequency at which the angle of the incidence equals 90 degrees, and the radio wave is refracted back to the Earth's surface. This is 90 degrees from the Earth's surface, not 90 degrees from the ionosphere. This signal is shot straight up and comes straight back down. Above the critical frequency, the radio waves penetrate the ionosphere and continue into space. The critical frequency is dependent on the electron density in the ionosphere. This is one such tool that we can use to determine the MUF and to look at different ways that we can select signals to make contacts with our amateur radio station. This is what I refer to as the MUF map, and is provided by kc2g.com. Thank you for doing that. Much appreciated. I'll include a link to this below so you'll be able to use it for yourself in the future. Now, when we take a look at this MUF map gives us a date and time stamp. It also gives us an estimated solar flare index number and an estimated sunspot number, which is useful information for determining our maximum usable frequency. Also, what you can see here are some bands that show us what our maximum usable frequencies are. So at this time, you can see over here in Europe, we have somewhere between 25, 26 to 30. Over here on the east coast of North America, we have somewhere between 30 and 31. So we may be able to use frequencies in the 10-meter band to make contacts to the northern parts of Europe. Down here in South America, you can see that we have frequencies of a MUF around 32 megahertz. It doesn't quite make the way to Africa, so we're not going to be able to use those frequencies that high, but we should be able to use a 10-meter frequency just fine. Also, we take a look over here at Australia. You can see on the northern tip, they're actually as high as 47. Now, as mentioned, different factors make up these MUF estimations, but this is a great tool that we can use to make predictions about communications with amateur radio. If you have any questions, comments, suggestions, or recommendations, go ahead and post them below and I'll do my best to respond. Thanks for watching, everybody.